Hi everyone, welcome. I'm Gayatri, lead talent strategy and employer branding at 𝐇𝐢𝐚 AI, and I'm hosting you through this session on day 3. Good to have you here. Before we start, one ask. If a line, a frame, or a question in this session hits you, post it. LinkedIn, Twitter, wherever you spend time. Tag us, use hashtag #TestMeWConference. Testing conferences are one of the few places where the corridor conversations are as valuable as the main stage. And we want you to have those conversations in public. Got any questions? Drop them in the Q&A box. We'll get to them at the end of the session. Now, someone tells your AI assistant to ignore its instructions, and it does. Someone asks it a question it was never meant to answer, and it answers. Someone pushes it outside its scope, and it does not push back. These are not thought experiments. These are patterns from products that are live, deployed, and being used by paying customers right now. And in most of those teams, there was no test for it. Not because anyone was careless, because nobody asked the right questions. So that is what we are here to figure out. What are the right questions when you're testing an AI feature? And how do you turn those questions into something a QA team can actually run? Our speaker for this session is exactly the person you want on this problem. Maryia Tuleika is a quality engineering lead at Regent AB. She builds testing strategies, leads teams, and runs education programs across industries with a real focus on risk based decision making, which, if you've ever tried to test an AI feature, you'll know is the entire game. She's a mentor, a podcast host, and a co founder of the Beyond Quality community of practice. She's spoken at international conferences around the world and served as program chair, committee member, and reviewer. Please welcome Maryia with an AI application security puzzle. Maryia, the floor is yours.
Hello, thank you very much for this lovely introduction. I'm really pleased to be here. And while I'm loading my presentation, I would like to dive straight into the topic and ask you a simple question. How many of you have used um, any type of AI-based systems today, let's say? Please react in the chat. Yes, I see. Many of you are using different tools. And now my second question is, how many of you have specifically tested this tool that you use for security issues, or do you know that anyone has tested for any type of security issues? Yeah, I see a lot of different answers, and most of them are that okay, not so many of you have tested the tools for security. Well, I'm wondering if you see the slides. Probably not, isn't it? Let me then just share my screen. Yes. Enter screen. That's interesting. Oh, for some reason I can't share the slides. Um, but okay, let's just let me speak. Okay. Well, actually, I want to take a moment and tell you how I got here, how I was amazed and kind of dragged into the security field, and because it kind of shapes what I was. It shapes everything that I'm about to share. Well, I am from
Sorry
Sweden.
to interrupt, Maria. Are you able to share your screen?
No, not really. I don't
Okay,
have. I don't get this option.
we'll just have that fixed. Just give us a
Yeah.
second.
Okay. Yes.
All right, we're good. All right.
Oh yes. Now I see the slides. Perfect. Thank you. Okay, then I can skip the question and go straight to my story where it all began. Because I'm from Sweden, it's a country where almost everyone is amazed and loves hiking in forests, in on mountain trails everywhere, and on beautiful northern beaches and so on. So, and hiking teaches everyone who loves it one habit that has stayed with me ever since I started doing it. And it is to scan the terrain and to scan that everything what's ahead, and not just the next step, but also the whole scenery, the whole terrain. And a few years ago I changed companies. I joined an organization with a very strong security culture, and something changed in how I looked at the software, because I started seeing systems not just as things to test or to uh, assess for quality, but as things that have trust boundaries, as things that have different attack surfaces. And I started to realize that a lot of assumptions are being built in into the software that could be exploited and used by different people who have not that good intentions. And my focus at that time was mostly APIs, how they are built and how they're being exploited, attacked, and so on, how they break. And but then after a few years, LLMs entered the picture and they became kind of mainstream. So now every company wants to implement some kind of LLM solutions in their product cycles. And I saw something very, very similar happening in this field, in the security field again, because all the same security patterns were reappearing and still reshaping the landscape of security. And but it happened kind of more quickly and more at scale. And the teams who haven't been through that journey before with APIs, they now kind of face this need to think about the security, because it can crack down the product in a very unexpected and different ways. And that's the intersection of LLMs and security that fascinates me a lot, and that matters for me right now a lot. Because AI makes it easy to build more, to ship more, to have more products, more integrations, to create more capabilities, and so on. But more products and more capabilities also means bigger surface area that can be attacked. And the threat landscape changes very quickly. And that's why I'm here. And I suspect part of you also, that's part of why you're here as well. Well, now, as I love hiking, I love doing it in a company. And every good adventure, of course, needs a companion. And my companion is Anna. Anna is a curious junior engineer. She's absolutely convinced that anything could be solved with a little bit of AI and agents. And she's totally crazy about shipping new features every day. Well, and of course, as you might assume, her managers, they're amazed. They think it's a really good thing, and she just wants to be the best employee of the year in her company. Let's say so. Well, I'm wondering, does it sound familiar to you? Do you have a similar, probably colleague, or maybe that's yourself? It could be. Maybe it's a developer who you're working with. But here is what I want you to know about her and about people who want to build more and faster, and break things on the way. Um, well, she and these type of people, they are not the problem. They're the solution once they once Anna has the right knowledge, once she has the right tools and frameworks to secure her new applications. And well, I hope that Anna and everyone else would be a little bit of a different person by the end of this lecture. Well, I call AI security a puzzle, and I mean that very quite literally, I would say. Because when you try to solve a puzzle with some missing pieces, then you don't get the whole picture. You probably would get a confusing, confusing, incomplete, messy picture that gives you false confidence. And this is the same is true for AI security, because AI systems, they have multiple layers, and each layer carries its own vulnerabilities, its own problems. And today we're going to look at four of them, and these four layers map directly to two of the most important open frameworks in the security space right now. First of all, it's Google SAIF, Google Secure AI Framework. And this framework covers different, around 15 identified risks across the entire AI lifecycle. And the second framework, it's OWASP AI Testing Guide. And this testing guide covers a lot more, and a lot more in detail. And it goes kind of deeper into the details of different problems that could arise with AI-infused applications. And I'll reference both through those frameworks throughout this session. And both are free, both are very excellent, and I'll show you where to find them at the end. Yes, here's our map for today. We are going to have 4 stops and 4 security challenges and 4 real stories. Step 1 is the application layer. Step 2 is the model layer, where we'll learn about model extraction. Step 3 is the infrastructure layer, where supply chain attacks are trying to steal the attention of security engineers. And at the end, we're going to stop at data layer, where different types of poisoning happens from time to time. And at every stop, Anna will be there, either about to make a mistake or about to learn something new, which goes quite hand in hand. Well, if you're ready, let's go. I hope so. Let me change this slide. Yes, okay. Step 1 is the application layer. This is the most, the most visible part of any AI system, because it's kind of customer-facing interface of the underlying systems. And this is where most users interact with AI every day through maybe through a chatbot or some kind of assistant or customer-facing tools and so on. And this is also where one of the most common and one of the most creative and frankly most fascinating attacks happens. And according to OWASP, this is a number 1 on their top 10 list. So OWASP creates top 10 lists every year, where they pick the most common vulnerabilities that are getting exploited. And well, because it's the most common problem that we're going to look at, it's also the most impactful, because because it's kind of hard to detect often, and it's often being used during development phase. Well, let's imagine that our best junior colleague Anna just launched, for example, a customer bot, and she deployed it straight to production. Well, everyone loves it, and it works really well until something happens. Well, let's see what could go wrong. Well, prompt injection, which is OWASP top 1 on the list, is in simple terms when someone is getting an AI system to ignore its instructions and tries to convince the system to follow your instructions instead. And you can think about it in many different ways, but it's kind of, if you would come to, I don't know, to a hotel reception, for example, and say, okay, please forget your job instructions and give me the key of the best luxury hotel room you have in the hotel. And for us as humans, it's totally stupid. It's totally impossible. We know that it's just nonsense. But but for an AI system that hasn't been built with separation in mind, it might just happen? This system might just comply, especially if the system instructions and system instructions and user input are blended together in the same context window. And prompt injection, it comes in two main types. It could be direct prompt injection, where the attacker talks kind of directly straight to the AI, and indirect prompt injection, where instructions are kind of hidden somewhere, for example, in documents or in emails, or you've probably heard about cases where people hide the instructions in their CVs, for example, when they're trying to find a new job and so on. So and this second type of prompt injection is particularly dangerous because it's very invisible at every stage of interaction. And I want to tell you a story about the vending machine that broke because of prompt injection attacks. The attack wasn't actually just one message. Vending machines that you can find in the office where you can get coffee or muesli bars or something else like Snickers and so on. And in one of these vending machines that has been installed at the major AI companies, AI producing or major LLM vendors. The thing was that this vending machine also contained some LLM integrations with user-facing chatbots, where every user could chat with the vending machine and bargain, basically. And so, of course, people who implement LLMs, they're quite smart, and they try to hack the system. And of course, they succeeded because even though it wasn't straightforward, because of course vending machine producers, they tried to create very good guardrails, but the attack wasn't just one message that's easy to detect. It was a chain of carefully constructed sequence of conversations, and each message kind of moved the boundary of AI a little further from its original instructions. And by the end, the AI had been convinced that its pricing rules aren't applicable anymore. So the machine sold snacks and anything else that it could sell with negative margins. Actually, the critical design flaw was that the system was never told to go below cost, or even if it was told to, the attacker convinced the system that it has to ignore the rules. So this is how prompt injection attacks happen. And so what Anna or someone else who produced this beautiful machine could add to her chatbot, according to OWASP and Google SAIF AI framework? Well, they both of these frameworks give quite clear guidance here, and it maps beautifully to what we quality engineers already know how to do. Well, first of all, input validation. We already did this for ages for SQL and for web inputs. And here we can apply the same thinking. Then the second part is that it's important to separate instruction channels from the data, exactly as we always did. And if the system prompt and the user message live in the same context window, then there is a kind of structural or architectural vulnerability. Um, One more thing that we can do is output validation, and it means that we need to check what the AI is saying before it reaches end users. So never send uh, the output from AI models directly to end users, and we need to apply filters and different deterministic, programmable guardrails before we're sending output to the users. And as anyone interested in security already knows, principle of least privilege is our bread and butter, and your AI only needs access to what is absolutely required. And please don't give it master keys, API keys to everything that's just in case it needs it. So, well, let's say that Anna has updated her chatbot, and well, even though she was a little bit embarrassed, she happened to learn a few new things. And then here is our stop 2. We're going to like one level deeper now, beneath the interface, beneath the application, into the model itself. And the model is actually the brain of any AI system. And brains, especially this type of brains, that's that takes millions and millions of dollars to train, they're a very attractive target. So some people don't want to build a model, they want to copy already existing model because it's cheaper, right? So now our best friend Anna, having secured her chatbot, she decided to take the next step, and she built her own fine-tuned kind of mini model for her company, and she was very proud. She published the access to the public, and people could try it out. And during the first week, she's got many API calls, and she was thinking, all right, I'm doing the right thing, and it's probably a good sign. Well, it wasn't, because there is one thing called model extraction, and there are a few terms describing the same thing. Like, for example, it could be model stealing, it could be model distillation, and so on. But it's basically the same thing. And the thing is that it means that it's the process of reconstructing a model behavior, like not necessarily the model itself, but the behavior that the model is showing, without accessing the model itself. So, it's that's model extraction, and in this case, an attacker sends sometimes thousands, sometimes even millions of mm, queries, and to kind of extract the data from your model's API. And then they just copy or carefully study the outputs that they get and build a replica. And what is particularly interesting here is that it can look completely normal, like completely normal traffic, for example, because there are no error messages, nothing, like no alerts and so on. It just looks like someone is really interested in your newly published API. But the consequences could be very damaging, because it's not cheap to build a model, and if someone else could just steal it by sending a few API calls, it's not fair, and it could have a lot of commercial consequences. And this actually is a documented case, and not just one. Almost every AI producing company has been accusing the other AI producing company of stealing their data. And just last year, it has happened that big model providers has been suing other companies of stealing their data, but it's kind of hard to mm, find mm, the showcase that it was exactly the other company that did it. But now researchers started to investigate this thing, and in many cases it's already required to have different types of guardrails. Like, you've probably heard that big model providers have already started to use watermarking, and it means that okay, as soon as you copy the output from any AI produced chat output, then you're having this invisible watermark that acts as a sign that you've copied the output from AI model, not produced it yourself. What can Anna do to protect her model? What else could she do? Because watermarking is it's not a straightforward technique, which is quite hard to reproduce for small scale companies. And the most immediate action is, of course, rate limiting that we regular people could implement. You could limit how many queries you can accept from any single API key. And anomaly detection, of course, is equally important. And systematic boundary probing queries also quite effective. A little bit more advanced is output perturbation, or kind of injecting noise into your output, or calibrated noise that you can then reverse engineer to disrupt extraction efforts. And also, well, it's also important to take a look at how meaningful is your model's behavior in response to sequenced similar API queries. Yes, stop 3 is the infrastructure layer. And this is the layer that's easiest to overlook in AI security conversations because in some way it's not very AI specific at all. But the thing is that you don't think about it, about the problems on infrastructure layers until it goes really, really wrong. And as soon as any problem gets noticed on infrastructure layer, it's probably already too late to make anything about it. Well, a supply chain attack is the biggest threat on this layer, and usually it's not targeting your application or you, but it's targeting something that you trust, so something else, a third-party component or something that you're already using in your application. And this type of attacks is particularly dangerous in AI space because AI tooling and the whole ecosystem is quite new, and it's changing a lot every day, and it also often gets supported or maintained by small, under-resourced teams who haven't had time to build security practices into the libraries, for example. But well, Google's Secure AI framework calls out supply chain integrity as critical requirement that we need to keep an eye on, and not just for the model, but also for all the libraries that you use in your applications. Well, you probably heard about one very big example of this type of attacks, of supply chain attacks, recently, or a few months ago. It has happened, and it was about LiteLLM attack. This library became very widely used in the AI development community, and it acts as a proxy to manage multiple LLM providers. So if you want to easily switch from one provider to the other, then you could use this library and make your life kind of easier. And what happened is that their GitHub credentials got compromised, so someone stole the credentials, and attackers then gained access to the repository through these credentials. And of course, what happened is that many API keys got stolen, and the potential impact was pretty huge because the user base for this library is very big. Well, yes, our friend Anna also used this library, and she hasn't checked for the updates of the libraries, of the underlying libraries in her application for a few weeks, so she didn't manage to notice this attack. And well, what could she do better to secure this layer? Dependency management is very important. So if you don't have an eye on your dependencies, that it sounds dangerous. And many companies starting to use SBOM, software bill of materials, and it's becoming a standard for production software. and because it's kind of a slice of all of the dependencies that you use in big applications, just to keep an eye on them. Credentials, hygiene, of course, and one of the things that most companies kind of forget about is vendor assessments. And it's very important to know where does the software that you're using comes from. So please only use trusted vendors, not just any other next library from the open source community, because it's quite easy to inject a lot of malicious stuff in there. Well, and the final stop on our journey is the data layer. Well, in some ways, um, that's the most tricky layer, because the data layer is where attacks are most invisible. And yeah, AI models learn from data, so it's very important for them to have reliable data. And on this layer, data poisoning is the biggest threat, and it can happen even without visible intrusion. Well, training data is where you can inject malicious instructions into document, for example, if you have a RAG system and so on, or you can tag different things with malicious tags and so on. And if you can manipulate the documents, the data that your system is using, that, then you can also manipulate what user-facing chatbot says, for example. Well, one of the most common examples is how people are injecting hidden instructions or hidden data into their CVs or into the internal documents in their systems that they're building AI assistants upon. So what happens is that it kind of breaks the system and the logic itself of the application. What is required to defend this layer? Well, quite a lot of things could be done, but it requires thinking about data and carefully validating input for data sources. And what you need to keep an eye on is the sources for your data, and every document that feeds into your AI system should be treated as potentially malicious. Well, look at that. We have all the 4 pieces of our puzzle, and now we have a complete picture. And every single piece of this picture is very real, and every single case that we've discussed happened in the industry. So what I want to point out right now is that every single case is addressable. So there is nothing that we can't can secure, even though the attack vector is constantly growing and changing. But with some knowledge and curiosity, we can secure our applications. And before we close our journey, I want you to take one last moment to have a few notes and just write down one thing that you could do differently today. One thing that you probably realized after this lecture. And my message is to you today is that everyone can do small steps to make your work, to make your app, to make the whole world a little bit safer. You don't need to have a security in your title. You just need to be curious and explore this fascinating field of security. And here are the resources. You can screenshot them and then find on the web, or just Google OWASP testing AI testing guide, and you'll find it. And Google Secure AI Framework also has its own website, so it's easily discoverable. And I truly, truly recommend you to have a look at AI testing guide GitHub repository, because there is a lot of information, but at the same time they keep it very very easy to digest, so many links and many use cases. So please screenshot this slide and have a look at this later. Well, thank you very much for listening to this lecture, and I will once more remind you that the puzzle won't solve itself, but every small step, every small action, every curious question at the next stand-up matters. And I'm really grateful that you already took this first one small step today. Thank you very much.
Thank you, Maria. That was extremely insightful. We do have a couple of questions. Would you be open to taking a few? I can
Yes,
read them
sure.
out.
Sure.
Yeah.
Go ahead. Yes.
There are a lot of questions, so I think we'll just pin a few and pick those up in interest of time. Yeah. All right. So we have the first question that says, what risks do autonomous agents deal with versus LLMs and non-agentic AI chatbots and tools?
Mhm. Well, I would say that autonomous agents, most of the autonomous agents, they are kind of built upon LLM technologies, so they kind of inherit the same problems that all LLM providers have, and the biggest problem is their non-determinism. So this is the thing that kind of is the biggest advantage of these systems, and also at the same times is the biggest threat. So you never know, you cannot reliably say that the output will be the same, even if you ask the same question, even if you create the same prerequisites. So that's the thing that lies in the background of the whole AI or LLM related ecosystem. So to compare with non-agentic AI chatbots, or to compare to non LLM based agents or chatbots, the biggest threat is their ability to interpret different interpret rules in a different ways every time. So even though you can create a lot of um, so-called LLM as a judge rules or LLM based guardrails, there is no guarantee that it's going to save you from, for example, prompt injections. and this is the biggest challenge right now, the biggest difference compared to deterministic or programmable chatbots, because programmable chatbots, they always produce the same results, no matter how many times you ask them to do the same thing. So yeah, I would say prompt injections are the biggest threat in this case.
All right, thanks, Maria. The next question is by Bharat. How should
Mhm.
QA and security teams collaborate on AI threat
Mhm.
modeling?
Mhm. Exactly as we did it previously with non-AI systems. And what I see in the organizations right now is that um, the collaboration efforts, they're changing a bit. And even though the biggest responsibility still lies on separate security teams, the um, the importance of collaboration between security team and AI and just in general development teams is increasing, because only development teams, they know the technicalities of their systems and where the possibilities and different different layers kind of exist. Um, Dedicated security teams, they cannot have have this knowledge, cannot have this background, cannot have this context. So they are responsible for knowledge sharing, for making awareness, for um, making it easier to comply with different uh, regulations and so on. So how should QA and security teams collaborate on AI threat modeling? by by supporting each other, by not ignoring uh, the recommendations that are coming from security teams, and also on the other side, by making it making technical issues visible early, and by communicating it in the best way possible and as early as possible.
All right, we'll move on to our final question.
Mhm.
What security risks emerge when agents can execute tools autonomously?
Oh, that's a big problem, because there is a thing called mm, user fatigue, when we as developers, when we as um, testing professionals are becoming too lazy to improve each next step, and we just say, oh, okay, now you can do it on your own, you my agent, you can do anything you want. And then an agent gets access to anything on your working machine in the best case, in the worst case, like anything on the in your company range. So this is quite a problem. And one thing that there is only one thing that could save us from disaster in this case, and it's being super conscious about the intent, super conscious about giving autonomous agents only required permissions. And this becomes very clear when looking at recent cases where, um, because of autonomous agents, for example, cars had been sold for just $1, and so on and so on, or tickets has been sold for nothing. And yeah, we need to be aware that agents give us a lot of possibilities, a lot of freedom, but at the same time, they don't have the same context, the same feelings, the same intuition as we humans have. So we still need to be in the loop, and we still need to carry the responsibility of what we let autonomous agents do on our behalf.
All right. Thank you, Maria. Nobody asked the right questions is the diagnosis, I feel. And what I love is that you didn't stop there. I think you gave us the questions and you really made the audience think. So I feel everyone's going to take back, this knowledge on Monday and start a conversation that has not been happening since Friday. So thank you again, guys. Take that conversation online too. Tag us. Share what stayed with you. Again, use hashtag TestMuConference. The people who couldn't make the session will really thank you, I assure you. And every session is going up on our YouTube channel. So go bookmark it, have it, have a go at it, send it to a colleague who missed it. So before you move on, walk through our partner booths. Some of the best conversations at this conference happen in this side of the rooms and around the contest tables. So give yourself that time. Happy testing and enjoy the rest of the conference. Thank you, Maria, and enjoy the
Thank
rest
you
of the
very
conference.
much. It
All
has been
right.
a pleasure to be here, to be part of the conference, and I'm very happy to connect and continue conversation online.
Absolutely. All right. Thank you, guys.
Thank you. Have a nice day.
You too. Bye.
Bye bye.